Okay, so this is question one from the test the other day. So what we have is a circle and we have a line. Okay, so this circle here, then you have a line. The line probably goes in twice, right? So it hits the line twice. Then we're going to find the midpoint of this new. We're going to find the midpoint of this new line, making this our new diameter. And upon doing that, we're then going to find the equation of a new circle that has the two O points as its diameter, as shown. Okay, so first of all, we got to find our 2 points. So what we're going to do is we're going to get x on its own. So we're going to find out that x equals 20 minus 3y. So this is like a substitution to find out the points of intersection of the line and the circle. Okay, so now we know that x equals 20 minus 3y to be squared plus y squared minus 6 times 20 minus 3y minus 8y equals 0. Multiply it out. We're going to get 400, and this is going to be this part here. When we multiply this out, it's going to be 400. It's going to be minus 120y plus 9y squared plus their y squared minus 120 plus 18y minus 8y equals 0. Gonna have a look up all the y squareds. We got 10y squared. We got 120y, and then we have another 10y added onto that, so it's going to be minus 110y. And then we're going to have 400 minus 120 gives us 280. First of all, we're going to divide by 10. And we divide by 10, we're going to get y squared minus 11y plus 28 equals 0. Upon doing that, we're then going to find out that it's y minus 4, y minus 7 equals 0. Then what we know after that is that y equals 4, y equals 7. Now we got to find out the x values. So x equals 20 minus 3y. So x will equal 20 minus 3 times 4, which is going to give me 20 minus 12, which is 8. So that is the point 84. The next one is going to be the point x equals 20 minus 3 times 7, which is minus 1. So the next point is going to be minus 1, 7. Now, as stated before, this is the old circle. We had a line goes through at these 2 points here. We have minus 1, 7 there and 8, 4 there. We're going to do next, we're going to find the midpoint of the two of them to find the center of the new circle. Upon finding the center of the new circle, we will then get the equation of our new circle. So midpoint formula is x1 plus x2 over 2, y1 plus y2 all over 2. Okay, we're going to have is 8 plus minus 1 over 2. And then we're going to have 4 plus 7 over 2. Now we're going to be two fractions here. It's going to be 7 over 2. And the other one is going to be 11 over 2. Okay. And now next thing we need to do is we need to find our radius. So to find our radius, what we're going to do is we're going to do the distance formula between the two red dots. And when we do that distance formula, we're going to half it to find our radius. So the distance formula being x2 minus x1 squared plus y2 minus y1 squared. So what we're going to get this time around, we're going to have x1 y1 x2 y2. So we're going to have minus 1 minus 8 squared plus y2, which is going to be 7 minus 4 squared. And then we're going to have root 81 plus 9, and that's going to give me the square root of 90. Now square root of 90 in the calculator, if you put that into your calculator, you're going to get a 3 root 10. 3 root 10. And that's the diameter, okay, so the radius will be 3 over 2 root 10. Okay, so we'll have to fix that in a minute. Now, what I'm going to do next is I'm going to write down the equation of a circle, where it's going to be x minus h squared plus, actually we won't do that one, because that's a harder version. Actually, yeah, we will do that one, I suppose. Now we're going to do x minus h squared plus y minus k squared equals r squared. So what we can get here is going to be x minus 7 over 2. Because h value is the x value of the center circle, the k value is the y coordinate of the center circle, so it's only x minus 2 to be squared plus y minus 11 over 2 to be squared equals the radius squared. We're going to square this here. So we're going to divide our last, it was root 90. We're going to divide it by 2. We're going to square the answer, and we get 45 over 2. That there is the equation of our circle. Now, because it doesn't state a specific form, we can leave it like that. Well, some of you might want to multiply it out and make it look a bit more like that. It doesn't specifically say we have to, so we can leave it as is at the moment. Okay, part 2. Okay, so what we have on this question here is that we've drawn below is we draw a function f of x equals cos 3x. Now I'll circle that one now in green. Okay, so your original drawing was f of x equals cos 3x. Okay, and it was this green one here. So this is the original function we draw. Okay, so this here is our original. Goes up and down, and then all the way to the end. Okay, now the next thing it wants us to find is it wants us to sketch the graph of g of x equals cos x and h of x equals 2 cos 3x. I'm going to start off with h of x equals 2 cos 3x. We can see that it's very similar to our original function f dash x is equal to cos 3x, except it has a 2 in front of it. Okay, this 2 in front of it doubles the height. So I'm going to draw this one in red. All I have to do is double the height of the original green one, so I can put a red dot here. Stays the same. Double the height of the second one. Then stays the same because 2 times 0 is 0. Then I double the height of the green peak there. Red point there. Once again, double the point, double the green peak. Red point there. Double the green peak to get to there. Green peak there. There, there. And then just keep doubling its height. And as you can see, you get a perfect red diagram here. Okay, so we're just going to go up here, and then this is the graph of h of x. Okay, because it's double the original. There we go. Like so. And that's it there. Okay. Next thing we've got to do is graph cos x. Okay, now how do we going to graph cos x? Okay, well, what we're noticing is that pi is here. So let's do this in blue. So pi is located here in blue. Okay, and it's going to be, we can see that it's into 3 different sectors. Okay, so that's going to be pi over 3 is this sector here. This sector here is going to be 2 pi over 3. And then we're going to have another 4 pi over 3. It's going up in thirds every time. 5 pi over 3. And then 6 pi over 3 will be your this part here. Okay. So we see that pi lines up exactly there. And then we have our 2 pi, which is directly underneath our peak. Sorry, just ever so slightly out of phase here. 2 pi is there, and pi, sorry, excuse what I said last time. It's much better done in the papers. So pi is here, 2 pi is here. Now, I suppose what I could do, a really cheap method here, okay, would be to, you don't have to, only you have to do this because it's done properly in your book, but in a situation like this, okay, I'm just going to, what I'm going to do is I'm just going to measure out with my ruler. Okay, measurement tool. Okay, so you'll see I have a ruler or two up here. What I'm going to do with this ruler is I'm just going to measure the distance from 0 to pi. And just for argument's sake, I'm going to make it a nice round number like, I don't know, like 6. Okay, so what I can do now is I can say that, okay, well that would mean is that this one here is a third of the way up. This one there will be 2/3 of the way up, 5/3. And then what I can do with this system here is I can create a way to draw cos x. Okay, so all I have to do next is put this into calculator what cos x is. Now I'm going to have to put it in radian mode, so go for cos x. So I'm going to go modes, table function. I can see I'm in D, so shift setup. I want radians. Okay, I want to draw cos x, shift alpha x. Okay, I'm going to start at, let me see, what will I start at? I'll start up here on 0, and what I'll do next is I'm going to have to go up in intervals of, I'll go up in intervals of 30, okay, so my interval is going to be pi over 6. Pi over 6 is 30, okay, so pi over 6 is going to be pi divided by 6 is my interval, same thing as 30 degrees, and then my step is how often, sorry, go back to that again. I'm going to start at 0. I'm going to end at, that's 2 pi, so I'll end at roughly 3 pi maybe. 3 shift pi. My step is going to be pi over 6, so I'm going to go up in 30-degree shifts. Press equals here, and I'm going to get my 30-degree shifts to draw this graph, okay? So what we can see here is that the first one is 0, 1. Okay, so 0, 1 being here. Next one we're going to have is our first 30 degrees. 30 degrees is 0.86. Okay, so 0.86. We'd say that's about there. Then we're just going to keep on drawing these. Okay, the one after that, that's going to be so the first one was 30 degrees. Second one 60, which is going to be a half, which is around here. And then the one after that is going to be this one here is going to be when it's 180 degrees, that's roughly half of pi, so that's pi over 2, which is going to be here. Okay, and then we can draw the next one, which is going to be that was 180 degrees, this is 210 degrees, so minus a half, roughly around here. And then we're looking for when it's minus 1. When does it become minus 1? We see it there, pi radians, it's at minus 1. And then likewise we can now see that the peak, so we can draw this blue line here now. Okay, then next we'll see when it's next 0. When it's 0 next, it's going to be this here 4.71. okay, this 4.71 is pi is 3.1, so it's like pi and a half. Okay, so it's going to be pi 3. So what we're going to say about that one is that it's going to be it's halfway in between pi and 2 pi. So that means it's going to be 3 pi over 2. 3 pi over 2 in your calculator, guys, you'll notice that 3 pi over 2 is in fact that number there, 4.71. So you're just going to draw it up, then look for your next peak of 1. Just keep going up until you see your next peak of 1. There it is there. That is 2 pi is your next peak. And then your next one after that, your next 0 is going to be 7.8, so that is roughly the next half length of pi, and you got your third graph in there. Okay, sorry, not the best done. It's just I had to make my own version of this question. Now, oh yeah, there's another question underneath that. Find the coordinates of the point PB in the diagram. Okay, so where is the point B? Oh, sorry, the point P. So find the coordinates of the point P in the diagram. So that's capital P. So you can see that the point P is here. Now, the point P, we can use its point P is in between pi and 2 pi. Its height is worth 2, because we can see that it has a height of 2 going straight across. Okay, so what we can say is that, and the diagram of P, the diagram P is on the red diagram, which is 2 cos 3x. So 2 cos 3x equals 2. Okay, this implies that cos 3x equals 1. Okay, so cos 3x equals 1. Now, if I was to put this back into degrees, if I cos inverse 3x equals cos inverse 1. So I'm going to cos inverse 1. Cos inverse 1. And with cos inverse 1, I'm going to get 0. So there's several answers to this. 3x will equal 0. The next time, next one that's cos inverse 1 is 360. The one after that is 720. And the one after that is 1080. Because it's every 360 degrees that cos will equal 1. So look at this, for example. Cos 0 is 1. Cos 360 also 1. Cos 720 also 1. Okay, so we can say is that x therefore equals 0, 120, 360. Now we know that it occurs between pi and 2 pi. Oh sorry, it's not 360, it's 240 because it's divided by 3. So we're dividing all these numbers by 3, and it has to be the 240 because 240 occurs between pi and 2 pi, because pi is the same thing as 180 degrees and 240 is the same as 360 degrees. So remember, to turn an angle into radians, what you do is you get your angle, you divide it by 180 and you put a pi beside it. And what we get is 24 divided by 18, or 240 divided by 180, is going to be 4 over 3 pi. So the answer for that is 4 over 3 pi. Okay, moving on. Find the equation of a circuit that contains the point -2, 2 minus 6, 4 minus 2, and whose centre lies on 2x plus y plus 4. Okay, so what we're going to do here, guys, is we're going to use x squared plus y squared plus 2gx plus 2fy plus c equals 0. Okay, now the other thing to note of this question is that this the circle, which is the centre circle, which is the point minus g minus f, lies on this line here. So if I substitute minus g minus f into this equation, it should satisfy it. So it's going to be 2 times minus g plus minus f plus 4 equals 0, minus 2g minus f plus 4 equals 0. So that's one equation, okay? Now, what we're going to do with the other two is we're going to have to substitute them in and make some linear equations out of them. So that's equation A. Now to make equation B from this point here. So it's going to be 2 squared plus minus 6 squared. I'm substituting into this here. plus 2g times 2 plus 2f times minus 6 plus c, which I have no idea what it is, equals 0. I'm going to get 4g, and then it's going to be minus 12f, and then it's going to be 4 plus 36, which is 40, so plus c, and that's going to be 40 there. When we bring it over to your side, it's going to be minus 40, so that's one of your equations there, done in red. Okay, next one we're going to do after that is the purple one, which is 4 minus 2. Once again, plugging them into this equation here. Okay, so what we're going to get is 4 squared plus minus 2 squared plus 2g times 4 plus 2f times y, which is minus 2, plus c equals 0. What we're going to get is 20 plus 8g minus 4f plus c equals 0. 8g minus 4f plus c equals minus 20. Okay, there we go. So there you go there, okay. So we have 3 different equations and we got to go about solving them. Okay, so what I'm going to do first is I'm going to use equation B minus equation C. So B minus C, so it's going to be 4g. Let's leave this here separately. So it's going to be 4g minus 12f plus c equals minus 40. Going to take away c, which is minus 8g plus 4f minus c equals 20. I'm going to result in minus 4g minus 8f equals minus 20. Then I'm going to use it against this equation A, which is minus 2g minus f equals minus 4. Now, what I can do with this equation here is I'm going to divide it by 2, minus 2 in fact. Divide it by minus 2 to get 2g plus 4f equals 20. So I divide it by minus 2, which would make this here a plus 10. We then bring down this secondary equation to work with it, so it's going to be minus 2g minus f equals minus 4. We get 3f equals 6, f equals 2. Now we know that f equals 2, so it doesn't matter if I know what g is. So I'm just going to modify this equation above it. So when I modify this equation above it, I'm going to get a 2g, remember 2g to the right, 2g equals 4 minus f, 2g equals 4 minus 2, 2g equals 2, g equals 1. Now that I know that f is 2 and g is 1, I'm going to pick one of the other equations. We can probably take this one here as an example, and then I'm going to put in f equals 2 and g equals 1. So what happens next is 8 times 1 minus 4 times 2 plus c equals minus 20. 8 minus 8 goes to 0 plus c equals minus 20. Basically c is going to equal minus 20. Now I have f equals 2, g equals 1, c equals minus 20. The equation of this circle is x plus y squared plus 2gx plus 2fy plus c equals 0. So we're going to get here is x squared plus y squared. The g value is 1, so it's going to be plus 2x. The f value is 2, so it's going to be plus 4y. C value being minus 20 equal to 0. There's your equation there. Okay. Next one after that. The diagram below represents a bike chain which passes over two circular wheels with centers A and center B. The smaller circle has radius 4 centimeters and the larger has circle of radius 11. The length of AB is 25 centimeters. So this is A to B here. Common knowledge. So this is A to B here. Okay. So what we're going to do next is we're going to find out what we're going to do here. So this is 4 centimeters, and this is says section CD and FK are tangents to the circle. LB is drawn parallel to CD. It's drawn parallel to CD, which makes this a rectangle and makes this 4 centimeters. And because this is 11 centimeters, it makes this part 7 centimeters. And we have a right angle triangle in here now, because we have a right angle triangle that is basically 25 and 7. We have to use Pythagoras' theorem to find out the other side. So 25 squared equals x squared plus 7 squared. X squared equals 25 squared minus 7 squared. I get there is 576. Square root that and you get x equals 24. So we now know that this is 24. Being a rectangle, this makes CD also 24, and it will also make, just by symmetry I suppose, by symmetry it will also make FK, which is this part here, it will also make that 24. So what we've got now, I'm just going to shade it in green, is we've got this section here and this section here of the bike chain. What we're lacking is we're lacking the outside edge here, which is this edge here, and we're lacking this edge here. So that's what we have to find out, is those two major arcs, okay, to find out the rest of the question. So next thing we have to go about doing is finding the angle. Okay, so I'm going to try and find out, if I can find out this angle here, then I can find out what this angle here is. Okay, and I can try working out what is the arc. So if I was to draw another circle fairly quickly, and just do it from the center. So I'm just trying to work out, what is basically the major arc here. Okay, so what is the length of this major arc that the chain goes around? Okay, so I'm going to do, first and foremost, going to go back to my triangle, and I'm going to figure out this angle here. This angle is located here, so I can do cos inverse 7 over 25. Okay, so cos inverse 7 over 25, so we call it angle A. Cos A equals 7 over 25. A equals cos inverse 7 over 25. What is cos inverse 7 over 25? Is 73.74. So 73.74 degrees. Okay. Now, what we can do next is we can find out what is the outside. We can find out what is this one on the outside. Okay, this one on the outside is going to be 360 minus your 73.74. So 360 minus 73.74. And what we're going to get is 286.26. So 286.26. Okay. So this 286.26 is our angle. So there's a formula in the book, which is theta over 360 multiplied by 2 pi r. The radius of the large circle is going to be it's 11 centimeters. as it says here. So 11 centimeters is going to be a theta, and we know that theta is your 286.26. So this 286.26 divided by 360 multiplied by 2 pi multiplied by 11 divided by 360 multiplied by 2 pi multiplied by 11, and what you're going to get is 54 meters. So 54 point. Sorry guys, just one quick little mistake there, right? When I got the angle A was 73.74. So it's 360 minus 73.74 minus another 73.74. So it's 360 minus 73.74 minus another 73.74, and what we would have got there was 212.52. So this 212.52 is actually our angle in question, what we're trying to use, or 212.52. Okay, so this 212.52 divided by 360 is going to multiply by 2, multiply by pi, multiply by 11. What we get here is 40.8. So the length of our major arc there is 40.8 centimeters. Okay, once again, to reiterate what that was, it's this one here. This arc here is 40.8 centimeters. Now, okay, so the next part is also tricky. Okay, so remember we talked about that 73.74. So there's a right angle here. This is your 73.74. This makes this angle in here 90. It's going to make it 90 plus 73.74, and then you got to take that away from your 180, minus 180. Okay, and that gives you an angle of 16.26. Okay, this 16.26. Okay, that actually works both ways, as in it's if I make a second rectangle on the bottom, just exclude out your 25, that's also 16.26. Okay, now if I add in the two 90-degree angles here and here, so that's 90 degrees here, 90 degrees here, I can find out the full angle of this here and take it away from 360 to find the red angle here. So I'm looking at doing here is I'm going to get my I'm going to get two 90s, which is 180. I'm going to add on 16.26 twice. So add on 16.26 twice, and then I'm going to get was it 212.52. Oddly enough, same size as this angle here by symmetry. Take it away my 360, and what we're going to get is this is 147.48. So this is my 147.48. Have to get the minor arc of this one here. So on the this diagram here of the minor circle, what we have is two lines going here, and we have to find out the length of the minor arc, which is going to be shaded in red here. Okay, so this minor arc is going to be we know it's 147.48 degrees. 147.48 degrees. We know it has a radius of 4 centimeters. So once again, it's equal to theta over 360 multiplied by 2 pi r. 147.48 divided by 360 multiplied by 2 pi multiplied by 4. 47.48 divided by 360 multiplied by 2 multiplied by pi multiplied by 4. You get here is 10.296, or So 10.296. Finally, we got to add them all together. So we have our, if we go back to the start, just going to rub most of this out at this rate. Okay, so we're just going to go all the way back to the very beginning. Let's see exactly what we're asked for. We know that the two of these here are worth 24. So that's 24, that's 24. We know that this big one here, it's in green, is worth 40.8. We know that the small one here is worth 10.296. So the length of chain added together is going to be your 224s plus your 40.8 plus your 10.296. What you get there is going to be 99.096. Okay, so that's the length of your wheel. 99.096 centimeters chain length. Okay.